Hi, this is Tom Reardon, math teacher from Ohio, with another SAT problem to solve. We will show you two different ways to solve this. We encourage you to do this problem along with me. Pause the video as necessary. A baseball is thrown upwards from the edge of a cliff. While the ball is in flight, the height of the ball above the ground, h feet, at any given time, t seconds, after being thrown is provided by this equation right here. We're asked to find the sum of the initial height of the ball and the maximum height of the ball in feet. So to do this, let's go ahead and I'm going to type into y equals this equation into y equals in terms of x instead of t, get an appropriate window, and graph it. Now, some people think that's the flight of the ball, and it isn't. Okay, this is the height versus time. So when I trace, for example, it says at 4 seconds, this is the height of the ball, but that is not the actual path. So to help you see that, I'm going to change the mode here to parametric so that I can graph both the flight of the ball in brown and the height versus time in blue simultaneously. So let's go ahead and take a look at that. So here's the ball. It's at maximum height, and it starts to fall down and splat. Let's look at that one more time. The flight of the ball, height versus time. Now to answer these, isn't that pretty cool? So to answer these questions, I'm going to go back to function mode because that's what you're familiar with. But I did want you to see that. So the initial height of the ball, I'll find that by tracing. So the initial means at the start, so it's times 0. So when x is 0, the height of the ball is 100 feet. The maximum height is found by using the calculate menu, second trace. And maximum is number 4. Left bound, okay, that is the left bound 0, enter. Right bound, let's say maybe 6. And let's maybe go with maybe 4 as my guess. And my guess wasn't too bad. It turns out that that would be rounded to 3.5 seconds, and the height is 296. So if we add those, initial plus at the maximum, we'll get the D, 396. Here are those windows there or screenshots so that you can reproduce this if you need to. Pause as needed. The second way is more algebraic in nature. So we'll start off with the original equation, except I'm going to use y instead of h of t. What I want to do is complete the square, so I'm going to subtract 100 from each side. Divide each term by negative 16. So the two negatives divided make a positive. This simplifies to negative 7t. And so I'm going to add half of this coefficient squared to both sides, which is 49/4. Simplifying the left, we're getting negative y over 16 plus 37 over 2 equals, and then this is how this factors t minus 7 halves, the quantity squared. Subtract 37 halves from both sides, and multiply every term by negative 16. And you can see that at 7 halves, comma 296, we do have a maximum. And so our answer again is D, if it would cooperate here. Graphing calculator way is definitely a better way.